Today we're looking at how to test for symmetry in an equation. So what we're going to look at is how to determine whether a graph is going to be symmetric with respect to the x-axis, y-axis, or origin. So first, we say that a graph is symmetrical with respect to the x-axis if every point on our graph, xy, the point x and the opposite of y is also on the graph. And we'll talk a little bit more about what this means after we've gone through all of them. To determine whether a graph is symmetrical with respect to the y-axis, that means that every point xy that's on the graph, the opposite of xy is also on the graph. So if you have a point, for example, 3, 2 on the graph, then negative 3, 2 has to also be on the graph if it's going to be symmetric with respect to the y-axis. And then lastly, a graph is symmetrical with respect to the origin if every point xy that's on the graph, the opposite of x, the opposite of y is also on the graph. So again, if we had the point 3, 2, that means that in order for our graph to be symmetric with respect to the origin, the point negative 3, negative 2 would have to be on the graph. Now, if we're having to test this in an equation, how would we do that? So to test for symmetry with respect to the x-axis, what we would do is we would take y and replace it with its opposite, and then simplify that equation and test to see if those two equations are equivalent, the one we started with and the simplified form after we've replaced y with its opposite. To test for y-axis symmetry, we replace x with its opposite and then do the same thing, simplify and determine are those two equations equal. And lastly, to test for origin symmetry, we replace both x and y with their opposites and then check to see if our simplified equation would be equivalent. Alright, so let's take a look at this example. So first we need to plot the point 3, 4 and then plot the points that are symmetric with respect to the x-axis, y-axis, and origin to this point. So first let's plot this point 3, 1, 2, 3, 4. So here's our original point 3, 4. So in order for a point to be symmetric with respect to the x-axis to this point, we know that we have to take our original point and replace the y value with its opposite. So that should mean that the point 3, negative 4 would also be on the graph if our graph is symmetric with respect to the y-axis, or x-axis, sorry. So replacing the y value with its opposite, so 3 down 1, 2, 3, 4. So we have the point 3, negative 4. And you can see that this is symmetric with respect to the x-axis because we just took our point 3, 4 and then reflected it about the x-axis and it gave us our point 3, negative 4. So to plot the point that's symmetric to this one with respect to the y-axis, we're going to take our original point 3, 4 and we're going to replace the x-coordinate with its opposite, which is going to reflect it about the y-axis. So negative 3, 4 should be on the graph if we want to graph the point that is symmetric with respect to the y-axis to this. So we go left 1, 2, 3, up 1, 2, 3, 4, right here negative 3, 4, and this point is symmetric to this point with respect to the y-axis. And then lastly, symmetric with respect to the origin. What this is it's actually a double reflection, so you can think about it as reflecting about the y-axis and then about the x-axis, or you could think about it as a rotation of 180 degrees about the origin of this point. So if we're reflecting about the y and the x, that means that we're going to replace both the x and y with their opposites. So negative 3 and then negative 4. So we go 1, 2, 3 to the left and then down 1, 2, 3, 4. So negative 3, negative 4. And then that point is symmetric to this point with respect to the origin.